This is Note-Taking Guide 4.4 for Math 1. Today we're going to talk about explicit and recursive equations for arithmetic sequences. Those are a lot of big words, so let's kind of just go through the definitions and decide if we can figure out what the difference is. So the first thing we're going to talk about is what an explicit formula is, or an explicit equation. It's a formula for any term of the sequence, depending on the term number. So if I wanted to know the 24th term of a sequence, I could plug 24 into a formula and it would tell me the 24th term of a sequence. If I wanted to know the 100th term of a sequence, I could plug in the number 100 into the formula and it would tell me what the 100th number is of the sequence. So an explicit formula is really useful because it will find any number in the sequence for you. On the other hand, though, recursive is a little bit different. Recursive is a formula that will find you only the next term, and the only way you can do that is if you have the previous term. So if I know what the second term is, I can find the third term. If I know what the 23rd term is, I can find the 24th term. So it finds the exact next term in the sequence. So there's a formula here for explicit. This is the formula right here. I just want to remind you what the things stand for here. A1 is the first term in the sequence. So that's what A1 stands for, the first term. D in this formula is the common difference. So what did I add or subtract to my sequence to get to the next number? And then the n right here is just the number of the sequence that I'm looking for. So if I want the 100th number in the sequence, then n is going to be 100. Okay, in the recursive formula, this notation is kind of funny and you've probably never seen it before, but what it says here, that n right here, the a parentheses n, that is what number of term are you looking for. So like the 100th term would be like a and then parentheses 100. So in order to find the 100th term, you would have to take the 99th term. So how did I know it was going to be the 99th term right there? Because it said the number minus 1. So if I'm looking for the 100th term, then I'm going to use the 99th term and then add the common difference to it. So in English, to find the recursive, or how to use the recursive one, it says right here, the previous term plus the common difference finds you the next term. There's two different ways that we wrote out the recursive formula. We did it with the parentheses and then we did it in function notation over here. So let's just see if we can use those formulas to figure out some math here. So this first problem right here says write an explicit formula in recursive form, then find the value of each term. So what we're going to do is I'm going to start by finding the value of each term because I have an n value here, which will be my term numbers here. So I'm going to substitute that n value of 1 in and see what happens. So I want to find my first term, so A1 equals 7 plus 3 times 1 minus 1. 1 minus 1 is 0. 0 times 3 is 0. So 7 plus 0 is 7. So the first term in my sequence is 7. So now I'm going to do the same thing. I accidentally erased my answer there. For the second term, so this time for my n value, I'm going to substitute in the number 2. So a sub 2 equals 7 plus 3 times 2 minus 1. And again, you can just plug that in your calculator exactly the way that it is there with the parentheses and everything. If you do that, it will just give you the answer on your calculator. So just take a minute and punch that in. So 7 plus 3 parentheses 2 minus 1, close your parentheses, and your calculator will give you the number 10. Now I want you to notice something right here because we already said that this was an arithmetic sequence. So I don't want to do any more work than I have to. So I want you to notice right here that in the formula, this number is the common difference. And if you notice from how I got from 7 to 10 right here, I added 3. Because this was arithmetic, I know I was going to add. So I'm just going to finish this by adding 3. So the next term, the third term would be 13. The next term would be 16 because I'm adding 3. The next term would be 19 because I'm adding 3. Now, the 39th term, on the other hand, is going to be a little bit more difficult to find because I don't want to keep going up to the 39th term by adding 3. That's a little bit more work than I want to do. So again, I'm going to go back to the formula here, and I'm going to find the 39th term. So a sub 39 equals 7 plus 3 times 39 minus 1. And I'm just going to plug that stuff into the formula here. So 7 plus 3 times 39 minus 1. Put in exactly the way it appears with the parentheses and everything, and then just punch it in, and when I did that I got 121 for my answer. So it was actually really nice here that we could just plug into that formula and get the solution out. So the other part of the question is says to rewrite the formula in a different way. So I want to just look at this formula for just a minute. I have a sub n equals 7 plus 3 times n minus 1. I'm just going to solve this for you and show you what happens. So I have 7 plus 3 times n, and then that multiplies to be 3. I'm going to combine these together. So 3n plus 4 is how I would get my term. So say I want my first term. I would go 3 times 1 plus 4. 3 times 1 is 3. 3 plus 4 is 7. So this formula also worked to find the next term, or the term that I was looking for, even though it was more simplified. So just keep that in mind. Okay, same thing again here. And it might be easier to just simplify that formula first so that we can plug it in. If I simplify this formula first, I would have negative 4 plus 2n minus 2 by multiplying that through. That's going to be what my a sub n is equal to. So a sub n equals the negative 4 and the negative 2 make a negative 6. So 2n minus 6. And then that will make it really easy to plug into. So if I take 1 and I plug it in, I would have 2 times 1 minus 6. So that would be a negative 4 if I plug that in on my calculator. I put the next term in, I would have 2 times 2 minus 6, which would be a negative 2. Now you can again be reminded that this was our common difference, so I can find the next 3 terms just by using my common difference, which was adding 2. So if I go negative 2 plus 2, I get 0. If I do 0 plus 2, I get 2. If I do 2 plus 2, I get 4. But again, back down to that 52nd term, I got to go back to the formula. So 2 times 52 minus 6. Just punch it in your calculator. And when I do that, I get 98 for my 52nd term of this sequence. Okay, so we could have substituted right back into this original one like we did last time. It would have worked the same way. So if you like it that way better, that's okay. Or you could simplify it first and then sub into it that way. All right, this one tells me that my first term is 16. So I'm just going to put in my first term of 16 in my chart, and then it gives me my formula again. So this is an explicit formula because this one's, I'm sorry, a recursive formula because this one says take the previous term and add 10 to it. So if this term is 16, I'm going to add 10 to that, and I'm going to get 26 here. I'm going to get 36 here, 46 here, and 56 here. But I really can't use that formula to find the 62nd term. So what I'm going to do now is I'm going to go back and I'm going to use that formula to find the explicit formula. If you remember, we did it the other day. That formula was a sub n equals a1 plus the common difference times n minus 1. I know that my a1 value is 16. My common difference is 10 because I added 10. And then I can just plug it in like that. So when I'm looking for my 62nd term now, I can just put 62 into that formula. So 16 plus 10 times 62 minus 1. You can punch it in your calculator again exactly the way that that appears. So 16 plus 10, put your parentheses and then do 62 minus 1, close your parentheses. And your answer on this is going to be 626. So that was easier to do by the formula for sure, because we don't want to have to keep adding 10, adding 10, adding 10 until we get to the last number, the 62nd one we're looking for. All right, one more just like that. Here is my first term, number 5. And then this says take my term, my previous term, and add 4 to it. So I'm adding 4 to it, it would be 9. If I'm adding 4 to that, it would be 14. If I'm adding, 13 if I add 4 to that. Add 4 to that, get 17. Add 4 to that and get 21. So again, now I need to write my formula so I can find the 62nd one. So I'm just going to use that formula, AN equals A1 plus D times N minus 1. So my A1 value is 5. My common difference was 4. And then that's my formula. Probably in theory we should simplify that so that it's in the right form and slope y-intercept form. So we'd have 5 plus 4n minus 4. Combine those together and I would get 4n plus 1 for my formula. All right, you guys, thanks for watching this today. Good luck with your homework.